Hello students, in this lecture we are going to discuss some miscellaneous questions from trigonometric ratio. So far we have discussed so many things, and then we have a sum series and continued product of some cosine series. But apart from all of these things, there are some couple of questions which, to solve this kind of question, we require a different approach. Just have a look on this question. We have a cosine series on left hand side, and we need to prove that this expression is equals to cotangent x by 2 minus cotangent 2 to the power nx. How can we solve this question? So one of the way to solve this question is to shift each and every term from left hand side to right hand side. But do not try to convert each and every term of cosine into sine, because it will not give you any result. You have to think with the kind of term that you have. So if I try to shift one of the term cosecant x on the right hand side of this expression, then I'll have cotangent x by 2 minus cosec x on right hand side. So just for a moment, I'm just forgetting about this cot 2 to the power nx. And if I try to solve this to trigonometric function, I'll end up getting a cot x. I end up getting a cot x. You may convert this term into sine and cosine, but eventually cot x is what your result will be. Now please try to focus on the result part. If I shift a term cosec x on the right hand side of this expression, the argument of cotangent x by 2 will get doubled. Now we have a cot x. Now let us check whether this pattern will remain the same or it will change from the next term. Right now I'll be shifting cosec 2x on the right hand side of this expression. Now again, I'm just uh, ignoring cot 2 to the power nx for a moment. So the moment I shift cosec 2x on the left hand side, on the right hand side of this expression, I have to solve what will be the value of cot x minus cosec 2x. And if I try to convert this term into sine and cosine, I'll end up getting cot 2x as a result. Now again, it is a matter of concern there that each time what is happening, if I'm shifting every term of cosecant on the other side, then the argument of cotangent is getting doubled. So now instead of shifting each and every term, I'll be using a logic there. Say how many number of terms are there in left hand side, and if I'm shifting each and every term on other side, then what is happening in each and every time, the argument of cotangent is getting doubled. So if there are n plus 1 number of terms on left hand side of this expression, so what will happen, your argument x by 2 will get n plus 1 times, will get n plus 1 time. That means your eventually you will have cot 2 to the power nx. And now the term which I'm ignoring till the last will start appearing to me. This was cot 2 to the power nx. If I shift each and every term to the right hand side of this expression, that means I have nothing on left hand side. That means cot 2 to the power nx minus cot 2 to the power of nx, which eventually becomes 0. I'm sure you get it how by shifting each and every term on the right hand side of expression and dealing two term at a time will help me out to get the final answer. There is a more than this shifting of each and every term on the right hand side or left hand side of this expression. This is known as splitting of the middle term. Splitting of the terms is something which we have studied in sequence and series. Just have a look on this series and focus on your any one of the term. Just right now we'll taking care of the first term. We have the result in 10 in second. What will I do? I do feel comfortable in sine and cosine, so I'll convert this result in sine and cosine. So this result can be written as sine x by 2 over cos x by 2 times cos x. Correct. So whenever I have a terms of two consecutive terms of cos or consecutive terms of sine where difference of the angle will remain the same, this is the identity that you have to use. You have to use splitting of the term. As you can see on the another one, if I try to convert these trigonometric ratio in sine and cosine, this is something which what will I do? Sine x over 2 square divide by cosine
cosine x by 2 times cosine x by 2 square. So just have a look on their argument first of all. Can't you say that the difference between the argument is still the same in each and every term? If it is, then you are welcome to use this method. Now, what is this method actually? And according to this method, you need to create a difference. You need to create a difference of this angle in numerator as well as in denominator. So the difference of x and x by 2, it is by default x by 2 itself. And in the next step, you need to take sine angle. You need to consider a sine angle, sine of this difference of this angle. Since your numerator sine x by 2 is nothing, it defined the difference or is defined sine x minus x by 2 itself. So right now you don't have to do anything, because already the term you are looking for is present in numerator, that is sine x minus x by 2, and in denominator we have cosine x by 2 times cosine x. Now do the same for the next term. Difference between their argument, it is x by 2 minus x by 2 square, which is x by 2 square itself, and that is something which we have in numerator along with sine term. So this is the difference of argument along with sine ratio. And in denominator we have cosine x by 2 times cosine x by 2 square. You need to keep repeating this process up till all n terms, up till n terms. But if you try to get what actually pattern is, then you don't have to write down this expression unnecessarily. So now apply sine a minus b in the numerator, and at the same time divide this expression with cosine x into cosine x by 2. And do let me know what will you get. I'm sure from the first term this is something which you'll get, difference of tan x and tan x by 2. Am I right? Wherever if I switch to term number 2, then this difference will be there in 10 of course, but this time it is of tan x by 2 and tan x by 2 square. If n number of terms are there, I'm sure this pattern will keep moving on till the last term. So if n terms are there, can you guess what will be the argument corresponding to their tan angle? X by 2 to the power 0 is there as a first term of first expression of first term. X by 2 to the power 1 is there for the first term of second expression. So by default, we'll have x by 2 to the power n minus 1 as the first term of last expression. Along with this one, we will have obviously tan x by 2 to the power n. Now what will happen successfully, consecutive term will get cancelled out, and eventually we are left with only first term of first expression and last term of the last expression. I'm sure you understand what is the meaning of this splitting of product of the term. So that will lead you to your destination. This is its application part has been asked in JEE 2009 and one more time, I think in 2016. Their question is will still the same. There we have the series in cosine cosecant. So as of now we don't feel comfortable that much in cosecant. So what will I do? I'll convert this term of cosecant into sine one. So summation sigma time we have a sine theta plus m minus 1 times pi by 4, and there we have another term, it is sine theta plus m pi by 4. As I mentioned you earlier, if we have two consecutive terms of sine and cosine there, then we are free to use this method. The only condition is that the difference between the argument should remain the same till the last term. And since the difference between the terms will still remain the same, so what I am doing, rather than being specific this time, I will be applying this logic for its nth term. So say suppose this is its mth term, so I'm taking their difference of argument. As I told you earlier, the difference of argument, it is theta plus m pi by 4. Let me write it down. The first one, and the second one we have theta plus m minus 1 times pi by 4, correct? And now in the denominator I have to I have to write their difference, and if I try to calculate their difference, then I'll end up getting a pi by 4, correct? And now take a sign there, take a sign there. So now we have balance it out, apply sin a minus sin b in numerator, and let's check what we'll have at the end. So let me take out this 1 over sine pi by 4 outside of the box, and eventually we have cot theta minus m minus 1 times pi by 4 minus cot theta plus m pi by 4. The moment you start putting different values of m, since sigma sign was there, do not try to forget this thing that m will vary from 1 up till 6. So what will happen? Consecutive cancellation of the term will take place. So let me switch this sign pi by 4 on the other side and start putting different values of m there. For m equals to 1, I'll get cot theta, and on the other side this will be cot theta plus pi by 4, so on and so forth. I know cancellation of term will take place, so rather than wasting my precious time, let me write down its value when m will be equals to 6. For m equals to 6, I'll have cot theta minus 5 pi by 4, and then I'll have cot theta plus 6 pi by 4. This is something which is equals to 4 only. All right, so term cancellation of cancellation of term will take place. So eventually we have this two term cot theta minus cot 3 pi by 2 plus theta. Try to solve this question, you will get your answer. I'm sure you understand this method. Calculation part is not what I'm trying to portray to you right now, but just try to understand the logic. All right, so this is for this lecture. Thank you very much, you all.